this morning I got up and washed my face as usual, getting the beard very well in the process. And when I went to dry up the hairdryer, as I do, also to make sure it's nice and straight and not just all over the place like a bad beard, the hairdryer was just running as normal, and then suddenly the motor went down to half speed and it started getting very orangey and hot inside, so I stopped using it. Gave it a hot, turned it on again, and immediately started getting red hot again, so I thought, okay, time to explore this and see what's wrong. The construction of these means they're not actually great for maintenance, but we can explore the circuitry. I've already sourced a new hairdryer, so let's take this one completely to bits. So the first thing to note down here is quite interesting. This is missing its mica shield. The mica is a sort of bonded mica, and it's just the heatproof shield between this and the plastic. Here's the switch. It's a very simple switch. It's got 3 positions, off, medium and high. We'll look at that in the schematic because I've already reverse engineered this and drawn the schematic out, and I can tell you already that there are 3 sections of heat element in this. There's a very fine one, you can see it here, and its purpose is not just for heat, but it's also a resistive dropper for the little motor in there. That's a low voltage motor with a bridge rectifier, which you may actually, well, we're going to bring it out anyway, but here you can see the bridge rectifier tacked on the back of the motor just for discrete diodes. There's another diode here. That diode there is the low setting, and what it does is, aside from cutting out one of the heat elements, it puts a diode in series with not just the motor resistor, but also one of the other heat elements. And then you put up to the full setting, it bypasses the diode, and it powers 2 heat elements and the motor and its little in series resistor. Here's the fan at the back. So let's see if we can get access to this. Oh, things worth mentioning as well. This is a thermal fuse. It is rated 157 degrees Celsius, and there is the little bimetallic cutout under there that is designed for temporary just cutting in and out if you block the output, if you're doing something weird with your hairdryer, or the input gets blocked or snagged hair or something. The thermal fuse is the last resort. That's probably why it's quite a high temperature. This is the bit that if you leave it blocked for too long and the temperature builds up to the point the plastic's going to melt, that fuse then kills power to the whole device. You'll see that on the schematic. But in the meantime, I'm not sure the construction process of this. I get the feeling that they may wind the heat elements afterwards, and they're held in place with rivets. They're not soldered because A, the heat element material is not great for soldering onto it, and also it gets very hot and would demelt the solder. So it tends to be looped around little rivets that are crimped through onto the connections, the little bus bars inside, to avoid having plastic insulated wires up in a very hot area. The motor is down there, and I'm going to reach in. I'm wondering what is the construction technique of this, because maintenance of it is actually quite difficult. I'm cutting the motor connections at the moment. Is this going to let me pull off the outer heat element now? Yes, it is. There is the motor. I reckon that one of these diodes has failed, and that is what's causing problems. Let me get the power supply on and we'll try that. Okay, I've rigged up the power supply. We've got the bridge rectifier here, so this will work with theoretically either polarity, but it'll always run the right direction. And I've set this at 12 volts because I think that's the correct voltage. There is going to be noise, just warning in advance. That's good airflow. Now we're going to reverse those connections and see if it works in other polarity. Noting this is a true emulation of what's happening in real life. It's not working. It's hardly any current. That's it. One of the diodes has failed. Which diode? It's this diode here has failed. That's the problem. Okay. Because theoretically, actually, maybe this diode holds. We'll find out. Let's get the meter in. Interesting. Very interesting. So let's get the meter set to voltage, and we're getting approximately 11 volts across here. So if I go across the motor, we're obviously getting nothing across the motor. Well, not much, just a slight voltage. What is the voltage across this diode?
is science. I realize that for some people, this conversation itself will be controversial. The very fact that we're airing a conversation with Woody Allen. For those people, I would say, I'm reminded of a conversation I had with Ricky Gervais earlier at the beginning of our podcast, where he said that people that get angry that conversations happen that they don't want to hear. I like people who go downtown and see a sign saying guitar lessons for sale outside a door and say, I don't need any damn guitar lessons. Well, if you don't want a guitar lesson, don't go in. If this podcast brings some sense to you, don't listen to it. But if you do listen to it, I think you'll be fascinated. And I am particularly thankful that Woody Allen trusted me and our crew to come in earlier this year before the pandemic and have a long conversation in his studio in New York City. And I hope you'll enjoy it as much as I did when we had the conversation. So no further ado, Woody Allen.
I've already ascertained that there are the live goes on this bit here and switches from the first one at low setting and then a higher setting. Also the higher setting that bridges out these contacts down to this blue bar. We're declaring the colour neutral, but it's not. Purple was neutral for some odd reason.
Well, Woody, thanks so much for agreeing to do this. It's a big pleasure.
Sure.
Yeah, well, we'll see how you feel about that after this is over. There's so many things to want to talk to you about, but what I want to be, since this is kind of an origins podcast, I wanted to start with your origins. You didn't like the book. Yeah, and I read that you were injected early. Is everything true? Were you injected?
Hello, Alan. Hello, Alan.
Sure, you know,
Happy Christmas, chappers. Is it 4 weeks now? No, not
I went to college, so it was my freshman year. I took
Not just a total town nursery. Detention charge. 30th December 2025. And without further ado, Chicago. Alan's Psychedelic Christmas. Alan. Hello, Alan.